Hello, wonderful people. This lesson is on area of regular polygons. So obviously after today, you will be able to find the area of a regular polygon, but let's just talk about a few things before we jump into this. Regular, what does that mean? Regular means that all of your sides and your interior angles, or I guess angles in general, of your shape are the same. So regular means all your angles are equal and all of your sides are the same. So we are going to be able to find the area of all of these regular polygons today. So let's fill in some of these blanks here. It says the distance from the center of a polygon to any side is called the apothem or apothem. You can say it however you want, both are fine. But from the center of your polygon to the side, so this green segment I just drew in here, this is your apothem. I'll probably say apothem. Apothem works too, but there you are. That is your apothem. Now, the radius of a regular polygon is the distance from the center to the vertex. Remember, your vertex are where two sides meet. So the segment that goes from the center to where two of your sides meet is called your radius. And why do we call it a radius? Well, if you were to draw a circle around your regular polygon, which is dashed out here, do you guys see this circle that they have dashed in? Since your vertices lie on the circle, these would all be radii, all the way around. That's why that's called a radius. That looks really kind of like a mess, so we're just going to clean it up a bit. All right, there we go. So your formula for the area of a regular polygon is right here. Half times your apothem times your perimeter. Sometimes your examples are going to be really easy and straightforward, and you just punch it into your formula here. And sometimes they make you work for one of the two things, either your apothem or your perimeter, okay? So we'll start with some pretty easy examples. Oh, yep, we already knew that. All sides and angles are congruent. Bless. Okay. Let's start with some very basic examples here, kids. Just find the area of the regular polygon. So they're telling us it's regular, meaning all of our sides and angles of this triangle are the same. I'm going to write down our formula. Okay, so we need two things. We'll just label it out. We need an apothem. Well, luckily for us, they are giving us that information right here. Remember, your apothem goes from the center to the side of your triangle. So 7. Easy enough. Now our perimeter, remember that's if you were to walk all the way around your triangle, how far would you travel? Well, luckily for us, we know that all of these sides are the same, so they're all 24.2 feet. So we just have to simply take that times 3, and we'll get our perimeter of 72.6. Now, all we have to do is plug into our formula. So half times our apothem times our perimeter of 72.6. Type it into your calculator or into your phone, and we should get an area of 254.1 feet squared. There we are. Okay, how do we feel? Right, all we did there was plugged into the formula. Let's try another pretty basic example. So again, our formula, I'll write it off to the side here. Half our apothem times our perimeter. What is our apothem? Remember, your apothem goes from the center to the edge or to the side of your polygon. And I should note, it will make a right angle. It's always going to be perpendicular to that side. I guess that's another reason how you can know it's the apothem. I'm sorry, I forgot to mention that before. Okay, so we have our apothem is 16. And then remember, our perimeter is if we were to walk all the way around, and we know that one of our sides is 13.3. And this seems to be an octagon, so we have to multiply it by 8. So we get a total of 106.4. And now we simply just plug it in to our formula. So crunch those numbers out, and you should get about 851.2, what is our unit? Centimeters squared. So wouldn't it be nice if you always were just given everything you needed? Yes, that would be lovely. But unfortunately, it's not always like that in life, and it's just not always like that in math. So they're going to make us work a little bit harder on these next two examples. But it's, again, another thing you can handle. You just have to use that big brain of yours. So we have a nice little step-by-step process here. So what if you don't know the apothem or the side length? Well, here we go. Let's talk about it. So step 1 is to create a right triangle by drawing in the apothem and radius. So if we have, let's say, a hexagon like this, they want us to draw in your apothem. So I'm going to draw in. Whoop. There's our apothem. Here is our radius. Okay. If it makes your life easier, just draw it off to the side too. This is what we're dealing with. Okay. Number 2 says find the measure of the angle formed by the center of the polygon, the apothem, and the radius. So we are looking right now for this angle right here. That's the angle we're looking for, is this angle, like a different color right here. Okay, how do we do that? Well, highlight this for me. This is gold. This is what we need to do. So we're going to take 360, because that's how many degrees are in this circle here. We're going to take 360 divided by how many sides there are. So in this case, here would be 360 divided by 6, which gives us 60 degrees. Okay, and then we can divide it by 2, because the angle we just formed, or calculated, would be like for this whole angle here, but we only want half of it. So we gotta take that 60 and divide it by 2, and we get 30. So now this angle right here is 30 degrees. Once you have that angle, on step 3, you will use special right triangles. So our shortcuts of 45, 45, 90, or 30, 60, 90. Or if you don't have one of those fun angles, you have to use trig, so katoa, to find the apothem and or side length. So the big thing here that I really need you to do is highlight this part. Yep, where this guy right here. Yep. Yep, that's what you want. You take 360 divided by the number of sides, which was 6, and then take that number divided by 2. And that will give you this angle right here. All right, let's dive in and see how we do. It says find the area of the regular polygon. So right now, as is, we know our apothem. But we need to figure out what our perimeter is, correct? So we have to follow those 3 steps in order to find it. So step 1 is to draw in that right triangle. So here's our right triangle. And if you're like me and just, I don't know, things blowing up, I'm going to draw it huge right here. This is the triangle we're working with. We know that this is 5, and we eventually got to figure out what that side length is. Okay? So step 1 is we have to figure out what this angle is here. That's the angle we're looking for. So we're going to take our 360 divided by how many sides we have, which is 6, which we know is 60 degrees. And then we divide that by 2, so 30. So this angle here is 30, and this angle there is 30 as well. So now you can either use our special right triangles, which we've been doing for a very long time, or trig. I'm going to use special right triangles because it is faster and more efficient. So as of right now, I know my long leg is 5, and I'm looking for my short side. So how do I go from my long to my short? I have to divide by the square root of 3. And since we don't need to be exact anymore. We can just get this as a decimal. So 5 divided by root 3 is 2.89. So what we just found, folks, is this guy right here is 2.89. 89. 1 second here. 89. Okay, now don't get ahead of yourself. That is just this part right here. We need the entire length of that. So we have to double it, right? Because I need the whole thing. I just found half. So 2.89 times 2 gives us a side length of 5.78. So we just found our side length to be 5.78. All right. So now let's do what we were doing on those last examples over there. Our apothem is 5. Now we got to find our perimeter. Our side length is 5.78, and we have 6 sides. So multiply by 6, and we get 34.6. Now let's plug into our formula. Half times our apothem times our perimeter is approximately 86.6 meters squared. So it's kind of fun. Like, it's cool that we can rely on previous knowledge to help us solve this problem. It's cool that you guys are smart enough to find the area of this hexagon. Don't be fooled. This is not something easy. This is a lot of steps, and there's a lot of room for error. So if you're a little lost, that's okay. But just know that it's kind of cool, like once it clicks and once you get there. Okay. One more, and then we will do some more examples together in class. So same idea. We need to find the area of this regular polygon, and we're given the side length. So this time we're in need of our apothem. So if we follow our steps, we need to draw in our right triangle. So there's our radius. Here's our apothem. There's our right angle. Okay, again, because I don't know, I just need to see things. I'm old, apparently. This is my triangle. Okay, now look though, folks. This whole side is 14, but what would this bottom be? It'd be half of that, so this is just 7, right? Okay. So now, step 1, we need to find what our angle would be. So remember, take 360 divided by how many sides? This one's an octagon, so there's 8. Get 45. And remember to divide by 2, so 22.5. So we just found our angle that we're dealing with. It's 22.5. 22.5. Okay, now that's not a special angle to us, so we will have to rely on trig, which is okay. We love trig. And we are looking for our apothem, which is our guy right here. So this is what we're looking for. So if we label our sides, 7 would be our opposite, and x would be our adjacent. What trig function uses opposite adjacent? That would be tangent. So we'll have tangent of 22.5 equals 7 over x. So we know we're going to have to take 7 divided by tangent of 22.5. And we find that our apothem is 16.89. Okay. So like I just said, our apothem is 16.89. And now we can do our whole little song and dance. I'm going to go like this. I just need clear space. Okay. So our apothem is 16.89. We need to find our perimeter. We have one side length of 14, and we have 8 sides. So 14 times 8 gives us 112. Now plug into our formula. Half our apothem of 16.89 times our perimeter of 112 gives us a grand total of 945.84 units meters squared. Okay, super, we did it. Thank you for watching. I'll see you tomorrow. Don't worry, we'll do a bunch of examples together in class. I know this is kind of hard. I know it's kind of new, but I appreciate you for making it to the end of this video. We'll see you soon.